In this lecture, we'll understand how to draw the orbital diagrams of atoms of the first 20 elements. So basically, these are the diagrams that you would have seen in your textbook. So I'll take the first 20 elements and then I'll explain how to draw them. There are few things that I want to specify before I start this lecture. One, this lecture is, for absolute beginners. This lecture would be basically at grade 8 level. Absolute beginner who is just understanding how to draw these orbital diagrams. These orbital diagrams, they are based on the Bohr model. Bohr model is the most simplistic manner in which the orbital diagrams can be drawn. There is another complicated diagram of atom which you will understand in the higher grades. But as a beginner, Bohr model is orbital diagram based on Bohr model is good enough. Second thing that I want to share with you is that it always helps that if you remember the first 20 elements, do remember the symbols also. So, for example, symbol of nitrogen, symbol of sodium, symbol of potassium. So, these are the symbols that you should remember. At least for first 20 elements, you should. As a matter of fact, what I always suggest my students is that they should have a a uh, periodic table on their wall or on their desk. It helps a lot, especially once you start meeting serious topics in chemistry. It always helps to have a periodic table very handy. Stick it to your wall, stick it to your table wherever you are studying. Few other things. You have to understand these terminologies: atomic number, mass number, electronic configuration, the mass and charge of proton, electron, neutron. This would be required when I am discussing this. I have detailed lecture where I explain atomic number, mass number, all these terminologies. But in this lecture, I'll be just touching these topics. I won't be going into much of a detail. So with this background, let's start. So as you would be knowing, I'll just give you a brief of what a Bohr model is. Uh, what Mr. Niels Bohr was a famous scientist. He was a Nobel laureate, big name in physics. So the model that he gave was that he said that there is a nucleus at the center. There is a nucleus at the center, and there are concentric circles around it. Concentric circle means circles with the center, same center. So he said that there would be these uh, concentric circles around it, around the nucleus, in which the electrons will revolve. So basically, what he said was that nucleus will have a proton and neutrons, and the electrons would revolve around the nucleus in concentric circles. This is what Mr. Bohr had specified. Now, few properties of proton, electron, neutron that are very critical to us while we are discussing this. So first, I'll explain proton. So proton is a positively charged entity. It has a 1 unit charge. It has a 1 unit charge. See, please understand that this 1 unit is not 1 gram. It is not 1 kg. It is 1 unit. You'll understand in your textbook. You'll understand that what I'm trying to say. But just remember that the mass of proton is 1 unit. Mass of proton and mass of neutron is almost same. Almost same. Mass of neutron is also 1 unit. Is also 1 unit. Electron has a negligible mass compared to a proton or a neutron. So electron has a negligible mass. That is why I've said that this has negligible mass. So basically, if you understand what I'm trying to say, the mass of an atom basically depends upon the proton and a neutron. So proton and neutron, they stay in the nucleus. Proton and neutron, they stay in the nucleus. So what I'm trying to tell you is that the nucleus is the part of the atom where the mass sits. So this is where you'll have the mass, because in the orbital shells where electrons are there, electrons don't contribute much of a mass to the atom. So this is what you need to understand well. The charge is contributed by proton and electron. Neutron is neutral; it has no charge. So again, it is plus 1 unit charge, it is minus 1 unit charge. This is unit. This is unit. So again, charge is something which is measured in coulombs. You will understand. If you look at your textbook, you will understand. I don't want to go into again details. Uh, but here, what we have to understand is that the charge of a proton and a charge on an electron is the same, but proton is positively charged and electron is negatively charged. This is all that you need to understand. So basically, what I'm trying to say is that if I take a neutral atom, if I take a neutral atom, what is the meaning of neutral atom? A neutral atom is something which has a no net charge. It has no net charge. No net charge. What this implies is that number of protons is equal to number of electrons. So I hope this is making sense till here. If there is any doubt, let me take an example and then I'll explain. So let me take example of atom of sodium. So 23 Na11. Let me explain what this 23 Na11 means. So whenever you see a symbol like this Na is the element. In our case, this is sodium. This 11 will give you the number of protons. Now, in a sodium atom, which is neutral, sodium atom, which is neutral, the number of protons would be equal to the number of electrons. So 11 is the number of protons. So a neutral atom of sodium will have 11 protons and 11 electrons. If there is any confusion, please keep watching the lecture. By the time we complete the lecture, you will understand, most of the stuff. I'll try to make sure that you understand at least 80 to 90% of this topic. So, in a neutral sodium atom, the number of protons would be equal to 11. The number of electrons would be equal to 11. And another thing that you should remember is that there is something called, there's a property of atom, important property of atom, which is called the atomic number. So, atomic number is basically the number of protons of an atom. And as I have told you, in a neutral atom, the number of protons is equal to the number of electrons. So, that is why in this case, we can say that this 11 is basically the atomic number. So, what is atomic number? Atomic number is the number of protons in a in an atom, and because an atom is neutral, the number of protons is equal to number of electrons is equal to the atomic number. So, this is what you need to understand, and this is what is mentioned here. Please understand this. This is very important. The second thing that we need to understand is the meaning of this 23. This 23 is a mass number. So, what is a mass number? Mass number is number of protons plus number of neutrons. So, I take an atom, uh, the protons and neutrons sit in the nucleus, and the mass is contributed by the nucleus only. So, add the number of protons, add the number of neutrons, and you have the nucleus, the mass number. So, for example, in this case, you will have to do basic maths. So, I understand that this 23 is number of protons plus number of neutrons. From this, I understand that the number of protons is 11. So, 11 plus neutrons is equal to 23 and would be equal to 12. So, the number of neutrons would be equal to 12. So, if I have to draw the uh, orbital diagram of sodium, what do I need? I have understood that sodium, the information that I have is it has 11 protons, it has 11 electrons, and it has 12 neutrons. This is the information I can get from all the information that I can get from here. So let me put the 11 protons here, 12 neutrons here, and now these 11 electrons have to be put in the shells around the sodium, in the sodium around the in the sodium atom. Now, how do I put the 11 electrons? Now, again, this rule of putting the electrons in various shells, uh, incidentally, the shells are named as K, L, M, N. So, for example, the first shell would be K, the name. The second is L. Then there would be a third shell. Let me make some space. Let me make some space. So my third, so this would be my first shell is K, second shell is L, and the third shell, when you are drawing the diagrams, you will have to use the compass. I'm just drawing the rough diagrams. You'll have to manage with this only. So the first shell is named K, the second is L, the third is M. So Mr. Niels Bohr gave us the rule of putting the electrons in these various shells. The formula, incidentally, that he gave was 2n square, 2n square, where n is the number of the shell. So, for example, in the first shell, n is equal to 1. So, the maximum of 2 electrons can be put. So, what Mr. Bohr said was that, for example, when you have to draw the orbital diagram for sodium, you have 11 electrons. So, you will put 2 electrons in the first shell. Okay, so I'll put 2 electrons here, first shell. You can draw wherever you want in the first shell. Again, the formula that Mr. Bohr gave was 2n square, and in the second shell, n is equal to 2. So if I solve this, 2 to the 4, 4 to the 8. So in the second shell, I have to put 8 electrons. Why? See, I have 11 electrons that have to be put. I have put 2 electrons in the first shell, which is the K shell. I have 9 more electrons to go. But in the second shell, I can put only 8 electrons. So these 8 electrons would have to be put in the second shell. So 1, 2, 3, 4, 5, 6, 7, 8. So you can draw wherever you want. It is not a rule that they have to be put directly in opposite to each other, wherever you want to put. But there should be 2 electrons in the first shell. There should be 8 electrons. Now I have put 10 electrons. So how many electrons are remaining? I had 11 electrons. So 2 and 8. 1 is remaining, and the 1 remaining will go to the M shell. M shell. So this is how. So this is how you will draw the orbital diagram. And I think you might have done this in your school also, or in your textbook also. This 281, this is called the electronic configuration. So 2 electrons in the K shell, which is the first shell, 8 electrons in the second shell, which is the L shell, and 1 electron in the third shell, which is M. So this is how we draw the diagram. So this is the K shell, this is the L shell, this is the M shell. And 281, this is called the electronic configuration. What is electronic configuration? Electronic configuration is basically how we put electrons uh, in the various shells around the nucleus. So, you know, basically all that I wanted to tell you in this lecture, I have already told. Now we'll do some practice. But before I go ahead, I'll just review what we have done till now. We have understood that Bohr model is basically one of the model that we have to draw the orbital structures. In higher grades, you will understand there is another model also. Uh, Incidentally, if you look on YouTube or Google, you might find that. We understood what is atomic number. Atomic number is number of protons, and in a neutral atom, number of protons is equal to number of electrons. We understood what is mass number. Mass number is number of protons plus number of neutrons, because electrons don't have a negligible mass, so they don't contribute to the mass of the atom. We understood what is the electronic configuration. We understood that there is a formula given by Mr. Niels Bohr, 2n square, where n is the shell that you are talking about. That is the first shell, the second shell, the third shell. So, for example, let me explain this in bit of detail. So, first shell, second shell, third shell, fourth shell. So, first shell will have 2 electrons maximum. maximum number can be 2. In the second shell, you can have 2 to the 4, 8 electrons. This is the maximum you can have. In the third shell, 3 3 the 9, 9 to the 18, 18 electrons maximum allowed. In the fourth shell, 4 4 the 16, 16 to the 32, 32 electrons are the maximum electrons that are allowed in the fourth shell. This rule was given by Mr. Niels Bohr. He did the calculations and he gave us these results. Experimentally also, certain things that he had predicted came true. And we draw a simple diagram of sodium. We understood what is a neutral atom. We understood what is a electronic configuration. Now let me take another example. Another simple example that we can take is of chlorine. Chlorine. So chlorine, 35, if you see here, I have zoomed 35 Cl17. 35 Cl17. Whatever I am discussing is available in your textbook also. So, if I am missing anything, please refer to your textbook, or if you are not able to see properly for any reason, you can look at your textbook also. So, as I have told you, this 35 is a mass number. This is the mass number. This 17 is the atomic number. What does the atomic number give us? It gives us the number of protons. It gives us the number of electrons. So, our number of protons or number of electrons is both equal to 17. What does the mass number give us? Mass number gives us the number of protons plus neutrons. This is equal to 35. I have understood that proton is 17. When I calculate, the neutrons would be 18. So, when I draw the diagram, in the nucleus, there will be 17 protons and there will be 18 neutrons, and these 17 electrons would have to be put in the various shells. So, first shell 2, second shell, uh, in the first shell there will be 2 electrons, in the second shell there will be 8 electrons, in the third shell 2 plus 8 is 10, 7 is remaining. So, 7 electrons in the third shell. So, this is what the diagram would look like. So, 17 protons and 18 neutrons. The first shell has 2 electrons, then 8 electrons, then 7 electrons. So, the electronic configuration is 2, 8, 7. There is something called a valency, which you can look at when you look at a orbital diagram. You can understand what is a valency. That is something which I won't be explaining in this lecture. As I have told you, I have another detailed lecture in which I'll put the link here where I have discussed all these things. So, when I have to draw the diagram, I'll have a nucleus, then I'll draw the first shell, second shell, third shell. These would be concentric circles, and then the diagram would be drawn. Let me take, say, another simple example. You can take lithium. So, for example, 7 Li3. So, 7 Li3. So, 3 would be the number of protons, would be the number of electrons. From here, I'll get the neutrons. The neutrons would be equal to 4. So, I'll have 3 protons, 4 neutrons sitting here. The first shell will have 2 electrons. The number of electrons that I have is 3. So, 2 in the first and 1 electron in the second. So, this would be the nucleus. I'm just sort of shading it, and 2 in the first shell and 1 in the next shell. So, this is how you can draw the diagrams. You should be able to draw the first 20 elements. You should remember the name of the first 20 elements. You should know the symbol. Once you know the first 20 elements, atomic number is something that you will remember, because if this is a 20, calcium is 20th element, so the atomic number is 20. Mass number, with practice you will also understand the mass number. There is something called isotopes. Again, isotopes is something which I'm not discussing here. So I hope everything is clear till here. I've tried to make it as simple as possible for a beginner who is facing some difficulty in drawing the Bohr model of atoms. So please comment if there is any doubt. Please refer to the other lectures regarding atomic number, mass number. I'll put the links here, and let's meet in the next lecture.